we've been talking a lot about charges and how they're changing. So just to make it more redox flavored, right? So from now on, we're going to stop calling it charges. We're going to start calling them oxidation numbers, right? Now, some quick references. Group 1 elements are always positive 1. Well, you already know that they have a positive charge. They can only form ions with a positive charge. When group 1 elements, when they're bonded to something which is not themselves, right? If they're in ionic form, it'll be +1 all the time. Now don't get confused. It's just going to be +1 if they're asking for the oxidation of that number. So if they're asking for it, you need to calculate it. Maybe they're tricking you and it's something else, right? So just be aware of that and don't rely on this. You have to calculate it every time. So, if it's asking for it. Group 2 elements are always +2 when they're bonded to something. On their own, they're going to be 0, right? Group 3 elements are always, fluorine is always -1. Note how it's saying, not talking about chlorine or anything. Oxygen, just ignore the nearly always. Just consider oxygen being always -2, unless it's it's combined with fluorine or something. Just like, let's assume we'll cross that bridge, when we get there. Oxygen is always -2. Okay? All right, let's talk about more of them. Hydrogen will always have a +1 charge. If you have these notes, just scratch this out, right? For now. We'll come back to this when we get back to this. Okay? For now, you need to know, let's simplify it, it's always +1. Okay? Where an element is not combined with other elements, its atoms are in oxidation state of 0. Yes. And I've kind of explained why, because their charge is 0, right? Now, magnesium, before it reacted, had an oxidation or a charge of 0, right? O2 was 0. CO2? No, it's not bonded to itself. It's not in its elemental form. Fluorine? Yep, 0. What else can I think of? Sodium? Anything as long as it's just bonded to itself or in its elemental state, right? It's going to be 0. Okay, transition elements will have variable oxidation states. And you've kind of seen this where iron is 2+ sometimes, then iron is 3+ sometimes. Copper is just plus, and copper is 2+. How do we know it? We don't really know it. ये normal अक्सर होता है. How do we find it out? Well, we'll have to be clever with our oxidation calculations. So we're going there where we calculate their oxidation numbers and identify what their state is, their oxidation state. Okay? Let's move on. Now, oxidation states is very synonymous or exchangeable with charge, but think of it, oxidation state, as it tells you how many electrons something has lost or gained or in forming a compound, right? Obviously, because the charge does the same thing. But think of it this way. If an oxidation number of something is increasing, going more positive, it's oxidizing. Let me write that down. Oxidation can be also considered as oxidation number, or the value of the charge is becoming more and more positive or less negative. Oxidation number is increasing, and we'll see such examples. Another way of looking at reduction is that reduction is the oxidation number. It's not called the reducing number, right? It's the same thing. Oxidation number will decrease, the opposite of it, right? Here's an example. Magnesium with a positive charge turns into magnesium metal. Sorry, 2 positive, right? Magnesium normally has a 2 positive charge. What's happening to the charge? Well, it's turning into 0. This is also the oxidation number. It's from 2 positive, it's turning into 0. Is it increasing or decreasing? Let me also write that down. 0. Well, the oxidation number is decreasing. It's reducing then, right? All right. Though it is not true, I'm just reiterating it by reading it out, that though it is not true, you can see oxidation state as a charge on a particular atom. Are they interchangeable? Are they the same value? Are they exactly the same? Yes. But are they exactly the same? Well, not really, right? So oxidation states are considered something different, but they're literally the same thing as charges, right? Let's move on. All right, in the last 3 slides or so, we were talking 4 slides, three slides, all right? We were trying to figure out oxidation numbers and trying to set a bit of structure, get a bit of structure. And why is this important is because any compound is a compound because it has no charge on it. By no charge on it, what I'm trying to say is, if we're looking at magnesium chloride has an overall oxidation state of 0. The entire thing has a 0 charge or a 0 oxidation state. Why is it 0? Well, its constituent elements are giving me that charge, and the sum of those charges are making it 0. Here's why, or here's how do we do it. Here's how we work it out. Okay? Magnesium, so the entire, let's say the charge on magnesium is X, right? I don't know what it is. It's X. Plus whatever the charge is applied by chlorine, let's call it Y, right? And when I add them, it'll equal to 0. But hold on just a minute. There are 2 chlorines, not 1. So if there are 2 chlorines, the charge should double, right? Now they should balance to 0. And I'm so familiar with this magnesium chloride because magnesium is in group 2 and chlorine is in group 17. I know each chlorine has a charge of -1 or oxidation state of -1, where each magnesium, well, only magnesium, the only magnesium over here, bichara, has a charge of 2 plus, right? 2, oh my god, wait a minute, 2. So X is positive 2 plus 2 times Y is the charge for chlorine, which is -1, equals to 0, and I add them, it's all 0, man. It was always 0, always has been, right? So this is exactly what's going on. We kind of use this same logic in a different way, where we try to balance the charges out to find out the chemical formula for a compound, like यहाँ पे 2 plus है, यहाँ पे same logic. We're just being a little more technical and looking through the same problem through a different lens. Now, why is this useful is because I can create, let's say I already knew the 2 charges, right? I already knew both of the charges. Let's say I didn't know magnesium ka charge. So I could make the same equation up, X plus 2Y, right? And I could say confidently that they all equal to 0. It equals to 0 because it's a compound, overall charge is 0. So the total number of electrons over here match the total number of protons in there. Or in other words, the oxidation number for all of these is all sums up to 0. Okay? Now I don't know magnesium, so X is my unknown, where Y is my known, and I know it's -1. Or maybe there's a question that's highlighted it, right? So X plus 2 minus 1 each equals to 0. X turns out to be positive 2. As X is my unknown charge for magnesium, and my equation is saying it's positive 2, magnesium के ऊपर क्या charge होना चाहिए? Well, that's, like a demonstration of how algebra can be useful. There you go, guys. Algebra does make sense. All right. So magnesium has a +2 charge, and this is how we find it out, right? And we'll do a lot of these questions in the next video.